is about the structure of atoms and ions. Define the term proton number. So how we define a proton number? What is the definition of a proton number? You can use
Number
it,
of positively charged. Number of positively charged.
but it's of 2 marks. Proton number. So number of proton present in the nucleus of an atom. 1 mark is for the number of the proton, and the second mark is for present inside the nucleus. So you have to learn this definition. Like you cannot mention positively charged. That will not give you any marks. It's a number of the protons present inside the nucleus of an atom. Then use the screen annotation, complete this table.
Sir, sorry, sir. I just cannot annotate with the mouse. It's very hard.
It's okay. It's not an issue. You can use the chat as well. Those who are not able to annotate or use this screen annotation, they can also use the chat to mention their answers. So this is about the number of proton, neutron, electron. That's correct. Then what term is used to describe atoms of same element such as magnesium 1224 and magnesium 12 and 26? Which term we use?
Isotopes.
So we call them as isotopes. Then explain why the chemical properties of magnesium 24 and 26 are
Same
same.
number of electrons in the outermost shell.
So they have the same number of electron in the outermost shell. That's why they have the same chemical property. 1 mark is for mentioning same number of electrons, and the second one is for outermost shell or in the last shell or valence shell. Because it's of 2 marks, so the distribution is same number of electron, that's 1 mark. In the outer shell, that's the another mark, second mark. Use screen annotation to complete part C. You can also use a chat if you want to answer. Complete the table to identify the atoms and ions which have the following number of protons, neutron, electron. You can use a periodic table for this. If it is charge, mention the charge as well. You have to mention atomic number and atomic mass both. Not only the symbol, but what is the atomic number and what will be the atomic mass. And what about atomic number for chlorine? 17, that's right. And atomic mass, it will be, no, 35.5 is the average mass of the two isotopes. You have to mention according to this table. So when you mention the mass number, it will not be 35 because the mass number is a sum of proton and neutron. So 17 plus 20, that will be equal to 37. Then state electronic structure of the following atoms, following atom and ion. Electronic structure means how the electrons are arranged. First, for aluminium. Aluminium is having 13 electrons. So how the 13 electrons are arranged? Yeah, that's right. 283. What about sulfur? Sulfur is atomic number 16, means number of proton electron are 16 for sulfur atom. But it took 2 extra electrons. So you have to arrange 18 electrons. It's a sulfur ion. If it was a sulfur atom, then it will be 286. Because it's a sulfur ion, then it will be 2, 8, and 8. So you have to check the symbol, like what symbol is, whether it's an atom. If it's an atom, the number of proton and electron will be same. If it's an ion, a negative charge ion, so electron will be more. If it's a positive charge ion, then proton will be more. In this question, they mention Z is a covalent substance. In an experiment, a sample of pure Z was continually heated for 11 minutes. So it's a covalent substance and we heat it for 11 minutes. The graph shows how the temperature of a sample of a pure Z changes during the first 9 minutes. So they mentioned for first 9 minutes what's happening, but it is heated for 11 minutes. What is the melting point of Z? What is the melting point of Z according to
80.
the graph? So that's equal to 80, because when the temperature does not change, it means the state is changing. So it shows that the solid is changing into liquid. Or liquid can also change into gas, but in the question, the beginning, they mentioned that it is a solid. So if it is solid, so the state here, it will be solid. When the temperature does not change, it means the state is changing, so solid is changing into liquid, and at this point we have liquid. A sample of pure Z began to boil at 9 minutes and it boiled for 2 minutes. Use this information to sketch on the grid how the temperature of Z from 9 to 11 minutes. So what will happen from 9 to 11 minutes? The temperature will not change. Why the temperature will not change? Because it is boiling. So when it is boiling, its temperature will be constant from 9 minutes to 11 minutes. So it will be a horizontal line. Then a sample of pure Z was continually heated between 2 minutes and 5 minutes. Explain in terms of attractive force why there is no increase in temperature of a sample of pure Z between 2 minutes and 5 minutes. So what is the reason why the temperature does not change as it is melting? We are
The
supplying,
attractive forces become weaker.
yeah, so energy is used to break the force of attraction, or the attractive force become weaker. So distribution of the mark, I will show the distribution of the marks as well for this part. So 1 mark is for mentioning energy is used to break the bond or overcome the attraction. And second is between the molecule. So energy is used to break the bond between the molecule or overcome the attraction between the molecules. So if you write this, you will get 2 marks. Describe how the motion of particle of pure Z changes from 0 to 2 minutes. From 0 to 2 minutes, the temperature is increasing, and we know temperature and kinetic energy are directly proportional to each other. So if the temperature is changing, it means the kinetic energy will also change. So what happened from 0 minutes to 2 minutes?
Particles
So
get more kinetic energy and move faster.
yeah, particle have more kinetic energy, move faster. So and the distribution of the mark, when you mention vibration increases, the movement, the kinetic energy increases, you will get the marks. The experiment was repeated using a solid sample of impure Z. So now we don't have pure Z, we have impure Z. Suggest the difference, if any, in the melting point and boiling point of a sample of impure Z compared to a sample of pure Z. What happened to melting point if a substance is impure?
Increase.
The melting point. The melting
And
point
melting point decreases.
decrease, lower. Impurity is lower the melting point and increases the boiling point.
Yes.
So the melting point will be decreased where the boiling point will increase. A sample of pure Z was allowed to cool. Now it's a cooling curve. And keep in mind, as you sketch the heating curve, this was a heating curve. Just keep in mind the boiling temperature, the melting point is 80 and the boiling temperature is 220. So means it will condense at 220 and it will freeze at 80 because the melting point and freezing points are same and the boiling point and condensation point will also be same. So a sample of pure Z was allowed to cool from 120 to 20 degrees. The total time taken was 8 minutes. Starting at point X, so point X is given to you. Sketch on the grid how the temperature of a sample of a pure Z changes from between 0 minutes to 8 minutes, and keep in mind the boiling temperature is 220 where the freezing point is 80 degrees. And we have to sketch a graph from 120 to 20 for 8 minutes. So what will be the shape of the graph? You can use the screen annotation for this. Just a minute, I will zoom out so you can read the question and the values on the grid. You have to make till 20, like not below 20. At basically at 8, the temperature should be 20. So as you can see that that's right. The distribution, it will decrease from 120 to 80, then it will be horizontal. That is one mark. Then decrease from horizontal line and finish at 20 when the time is equals to 8 minutes. The duration for which it is freezing, the duration for which it is freezing, it's not mentioned, so you can make any duration for this, but the idea should be correct. Yeah, that's a correct graph. In the next question, zinc and copper are elements next to each other in a periodic table. Zinc is obtained from zinc blend in 2 steps. In step 1, zinc blend is converted into zinc oxide, and step 2, zinc oxide is converted into zinc in a blast furnace. Outline each of these steps are done. Outline how each of these steps are done. In your answer, give one chemical equation for each step and describe how zinc is removed from the blast furnace in step 2. So step 1, what happened? How a zinc blend is converted into zinc oxide. Zinc blend is zinc sulfide. How zinc sulfide is converted into zinc oxide?
Zinc sulfide plus oxygen is equal to zinc oxide and sulfur dioxide.
Yeah, so basically zinc blend burned or roasted in air to form. So zinc blend roasted in air to form zinc oxide and sulfur dioxide. So the chemical equation for this, it will be zinc sulfide plus oxygen. This will result in formation of so zinc sulfide plus oxygen, that's a balanced one, gives zinc oxide plus sulfur dioxide. Then step 2, what is step 2? Zinc oxide is converted into zinc in the blast furnace. So for this purpose, we can use coke, carbon or carbon monoxide. So how it is done? The second stage or step 2, how it is done, you can use the chat to convey your answers. Yeah, that's the equation. So zinc reacted with coke, or you can mention zinc oxide basically reacted with coke or carbon monoxide. Both are acceptable. So both equations are acceptable. You can see multiple answers are there for this part. So for the second, add or react with coke. So you can write reaction with coke. Even carbon monoxide is, because carbon monoxide is a reducing agent, so it can also be reduced by carbon monoxide. And the third thing, how we remove zinc. Carbon monoxide, even it's not shown here, but carbon monoxide is also used because it's a good reducing agent. But what we add first, we add a carbon, so that carbon can react with oxygen, give carbon dioxide. Carbon dioxide can react with more carbon to form carbon monoxide, and that carbon monoxide can reduce the zinc. Or what happened, the carbon which we are adding directly can react with zinc oxide and remove this oxygen from the zinc. The first one, because what happened, the first stage when carbon or the coke react with zinc oxide happen at a greater proportion, that's why the first one is a more appropriate answer. But the second step also happen, as the carbon monoxide is a reducing agent. Then the removal of zinc, how we remove zinc, because what happened, we use zinc is compared to other substances present in the furnace, zinc is having a low boiling point. So what we can do, we can use a distillation, like first we convert zinc into vapors and then condense back into liquid. Where for extraction of iron, distillation cannot be used because iron also having a high boiling point, so it does not vaporize at a temperature which the furnace is operated. Name the alloy. Alloy means mixture of the metal. Formed when zinc is mixed with copper. Which alloy is formed? Yeah, brass is an alloy of zinc and copper. And copper is in bronze in an alloy of copper and tin. The next part, copper is a transition element. It can have variable oxidation states. State two other chemical properties, the transition element which make different from group one. What are the two chemical properties? Not the physical, the chemical. Other than variable oxidation state, forming compounds, colored compounds. That's one thing. And can act as a catalyst. That's the second point. Or the element or their compound can be used as. Not all of them resist corrosion. That's why this is not valid for all. This is not a journal property that all of them resist corrosion. So these elements and their compounds can be used as. No, actually the formation of the colored compound, why it is refers to a chemical property, because it is related to the movement of electron, the transition of electrons. That's why it is refers to a chemical property. Due to a transition of the electron within the shells, they form colored compounds. Physical properties such as like melting point, boiling point, density, hardness, strength, these are the physical properties. A compound of copper can be used to test water. We can use a copper compound like anything there with copper to test the water, check the presence of water. State the full name of this compound of copper. That's anhydrous copper sulfate. Then state the color that occur when the water is added to this compound of copper, like copper sulfate. It will turn from white to blue. If it is cobalt 2 chloride, then it will turn from blue to pink. In the next question, aqueous potassium iodide Ki react with copper 2 sulfate to produce iodine. Balance the chemical equation for this reaction. Write the numbers to balance this equation. You can use a screen annotation or a chat to mention the balance equation. But we have here on, if I put 2, it's make 2 iodine, but on the right hand side I have 2 plus 1, 3 iodine. So this 2 will not balance iodine. What should be the balance equation? The balance equation for this? So 4Ki basically. Look, when you try to balance the equation, you start with oxygen followed by hydrogen and the last other element. But in this case, oxygen is already balanced. So you can select any other element. So example, for iodine, because I have the potassium is, compounds are both sides. So if I put 2, potassium is balanced, but iodine is not balanced. So I cannot put 2. But if I put 3, if I put 3 here, then I cannot make 3 potassium. So it cannot be balanced with number 3. If I put 4 here, I can balance potassium by putting 2. So potassium is balanced. What about iodine? 4 iodine, so 2 are already there. I put 2. Iodine is also balanced. And then I am left with copper and sulfate. So if I put 2, they are also balanced. Then deduce the charge of copper ion and copper iodide. So what will be the charge? As you can see, iodine belongs to group 7. So when element belongs to group 7, its charge is -1. Because there is no subscript for these elements, it means both have the same valency. So if -1 is for iodine, so copper should be +1. Otherwise, if the valencies are not same, example, copper was 2. So if copper was 2, then it should be CuI2, as the cross valencies we will multiply, cross multiply. So iodine valencies +1. In terms of electron transfer, why a copper is reduced? Why there is a reduction? Copper is +2 here, it become +1. Why we called copper is reduced? What is the definition of reduction? No, not displacement. The definition of oxidation or reduction is always in terms of
Reduction.
gain of
Reduction
electron
is
or
gain.
yeah. So reduction is gain. So in terms of electron, why a copper is reduced here? Because it gain electron. Whenever you write oxidation or reduction, it should always be in terms of electrons or oxygen, you can mention. But the best definition already they specify in the question in terms of electron. So it is gaining electron, that's why it is reduced. Identify the reducing agent. So the copper is reduced. Why copper is reduced? Because it is reacting with potassium iodide or iodide. Even Ki acceptable or iodide, because for potassium there is no change, for iodide there is a change, so we can say that is a reducing agent. So reduction happened for copper, and why reduction happened? Because it reacted with potassium iodide. So potassium iodide is acting like a reducing agent. So that was a balance equation, +1 gain electron, potassium iodide or iodide, both are can be referred as reducing agent. Because basically what happened for iodine, iodine is -1, it become, when the element is there, it does not have any charge. So that's 0. So iodide -1 becomes 0. So that is oxidation. So for a substance for which oxidation happen, that is acting like a reducing agent. And for substance which reduction happen, it is acting like an oxidizing agent. Ethanoic acid is a weak acid and hydrochloric acid is a strong acid. Both ethanoic acid and hydrochloric acid dissociate in aqueous solution. Explain the term acid. What is the definition of acid? So acids are proton donors. The chemical equation, the substance which donate proton or H plus ion, that's acid. All definitions are correct. The chemical equation shows the change which occur when a strong acid such as hydrochloric acid dissociate. Hydrochloric acid dissociate into H plus and Cl minus. Complete the equation to show a change which occur when a weak acid such as ethanoic acid is added to water. So when weak acid dissociate, first thing, their dissociation is not constant. So you should show a reversible reaction. And the charges till CH3COO, CH3COO is negative and H will be positive. So the reversible is not having marks, but why we show this one as reversible and the first one for strong acid does not show a reversible? Because strong acids ionize almost completely, like it dissociate into ion. That's why we represent only one direction arrow. But what happened, like weak acids, they can dissociate into ions, or ions can combine together and form back the molecule. That's why we represent by a reversible reaction sign. Now, a student does experiment to show hydrochloric acid is a strong acid and ethanoic acid is a weak acid. Student adds an excess of hydrochloric acid and excess of ethanoic acid to lumps of calcium carbonate. So calcium carbonate reacted with acid, it will give, whenever carbonate react with acid, it will give salt, water and carbon dioxide. uh, Only the identity of the acid is changed between the experiment. All other conditions are kept same. State 2 observation, which would show that hydrochloric acid is stronger than ethanoic acid. So rapid vigorous reaction or rapid bubbles will be there. Both cases it will be. So rapid formation of the bubbles or solid will dissolve at a faster rate. You can mention faster rate of fizzing, solid will disappear quicker, or fizzing will stop quicker because it react completely with that, because acid is in excess, or dissolving stop quicker for hydrochloric acid. Like because the reaction occur in a short time, that's why it will stop once all of the calcium carbonate is used up, because already they mentioned the acids are in excess. So if acids are in excess, the solid will be used up. So you can mention a rapid effervescence, rapid bubbles, fizz, or the solid will dissolve at a faster rate. The second, student uses the same size container and check the pressure is same for each experiment. State 3 other condition which must be kept same to ensure a fair testing. Volume of the acid used, that's one. The temperature, that's one. Amount of calcium carbonate, that's the third one. Surface area of the marble chip, that's also there. So any three you can write: temperature, as you all mentioned, volume, concentration of the acid, amount, and particle size or surface area. This is related to the moles question. So a hydrochloric acid produce salt called chlorides. Magnesium carbonate react with hydrochloric acid to produce magnesium chloride. A student uses 50 cm cube of 2 mole per dm cube hydrochloric acid in experiment to produce magnesium chloride. Calculate the mass in gram of magnesium carbonate needed to react with 50 cm cube of 2 mole per dm cube hydrochloric acid. First, calculate the number of moles of hydrochloric acid present in 50 cm cube 2 mole per dm cube HCl. So if I have the volume of the solution and I have the concentration, so which formula I should use to find the moles? So I will multiply them, because the moles is concentration multiplied by volume. So as the moles is equal to concentration multiplied by volume, but the volume should always be in dm cube. Concentration is 2 and the volume is 50 divided by 1000. So 2 multiplied by 0.05. What's the answer? It will be 0.1, I guess. Yeah, so 1 minute left. I will share another link and continue this question in the second session.